I'm Bill Ripley. I'm working with Alligator Designs. Alligator Designs is a systems integrator and manufacturer of parts and pieces, usually associated with systems. I like following the last presentation. That was a good insight for people that have been in the industry for quite a long time. I, too, came out of I was at Bell Helicopter for 23 years, building internally designed avionics systems and flight test equipment, and buying some hardware for simulators and flight test aircraft. And I was there for 23 years, so I got a pretty good knowledge, formed pretty strong opinions on, how we go buy things and how things are different now than they used to be, and trying to learn how to get the best relationships going between industry and the integrators. So let me find out why this is not working. It's on. Press hard. I want to do a shameless plug before we get started with the regular presentation. A lot of you guys that I've known for a long time realize that I've been with several of the companies that are pushing and coming up with a standard for VNX. VNX being VITA-74, small form factor conduction cooled module, and we'll talk about it some more during the VSO meeting. But the standard has now gone through committee, been voted on, and it's on its way to ANSI, which is a really good thing. It's like been birthing a baby, trying to get this thing up and running with all of the various sponsors we have around the industry. So that's a good thing. Keep an eye out for information on VITA-74. Now, what we're going to talk about today in the presentation is called Building a Hybrid Rugged Systems Using a Mix of Applicable Embedded Standards. And in the process of putting that presentation together, I put together some thoughts on the industry trends as far as selling systems to industry and what industry does, pushing us into a certain direction or another. Just couldn't really figure out how to change the title to have it reflect all that. So the statement of the problem is that the customer base is driving COTS providers to reduce SWaP-C, space, weight, power, cost. What's the best way to do that? That question doesn't have a single answer. It has a lot of answers depending on what the entire system looks like and how big it is, and the ratio between I/O and processors and the like. So the contention here, my statement, is that it's fairly easy to get really any 3 out of 4 of those, but sometimes the goals, will come up and be mutually exclusive. So we're talking today about a hybrid system, and in the case of the hybrid system, in a fairly large number of cases, will allow a system designer to use the best of all the standards. You can, with the right type of system opportunity, you can make more efficient use of the space, corresponding weight, et cetera. And you can right-size, what I call right-size, the chassis, the processor, I/O, sensors, and storage. You can make the box small. You can fit it into an envelope that you're given. You can right-size the performance, allowing you to put, for instance, a lot of I/O with a very low power processor, depending on what your sensor interfaces or I/O interfaces are. You can basically pick the right amount of processing capability for a particular application. And you can right-size the power, because not everybody needs, a Xeon class processor to do, some very basic functionality. And you can right-size, that's supposed to be cost, and I made a boo-boo. You can right-size the cost of the system, which is often being driven by the customers to be as low as possible. The paradigm over the last few decades has been where everything was built custom. In general, the costs have lowered, but not necessarily price. The size is generally reduced with technology. What we used to put in a 2-man lift box to go generate graphics on a fighter airplane on lots of displays can now be done in a very small box. The scalability and obsolescence management has definitely improved with the use of COTS, and the reusability actually becomes necessary so that the suppliers can, in a cost-effective way, go in and compete for the next project and the next project after that. Everybody likes to have something that's reusable, but you have to make sure that you do reusability carefully, because it can end up, you can end up with a real disaster if it's not applied correctly. Building systems, and I made a lot of generalizations here, just throwing out really round numbers, but the idea is that pretty much everything was custom, completely custom in pre-1970 days. Packaging standardized with the, ARINC 404, so things started, they made it so that in the case of avionics, all the boxes, they all sort of looked alike and they all fit together well in the trays, and so they developed an ecosystem that was based around ARINC 404. It's tried to, standardize the first, really successful internal architecture, with VME. Evolved VME into VPX using a lot of lessons learned and technology, increases. And then we started basically trying to go build everything to this preferred standard architecture. So we'd have a 3U compact PCI box, or a completely VPX box, or a complete VME box, and didn't really make any, in most cases didn't make any other accommodations to support multiple standards inside of a system. But there's been a trend lately, I'm not sure how big that trend is, but there's certainly a trend in the marketplace with people now that are building, looking to go solve their problems using hybrid systems. So you have to go in and look at the various standards that are out there and figure out which ones can actually play together, relatively nicely. So when I think of a system that is going to use multiple standards, I'm not really talking about a backplane per se, so I call it a midplane just because I had to call it something. So we have a midplane design, and on that midplane design, you can build this thing so you can accept a ComExpress, Type 6 or ComExpress Type 10, or various ComExpress modules that are out there. You can make it to work with 3U VPX. That tends to work pretty well for a midplane-based design. Vita74 VNX, my passion, is a good example as well, and we'll talk about that in a minute. As far as I/O, mini PCIe has really come a long way here in the last few years. People are actually building rugged and conduction coolable, where you can actually go in and conduction cool these cards and do a reasonably good job with it. We've done sufficient testing on the connectors and things like that to like it. There's a couple of companies. There's a company out there that's building a standard where they're trying to standardize the I/O configurations on mini PCIe. So there's two approaches that are in the marketplace for that have worked pretty well. And you can go in, and if you have essential I/O, things that you're going to need, you just put those on the midplane when you design a midplane. Sensor interfaces. Personally, I'm a real fan of XMC, so that's why it's XMC, XMC, and XMC. From that perspective. Storage modules, SATA, mSATA, NVMe, PCI Express. Lots of different options that work well for COT storage solutions. Power supplies, there are standards-based plug-in power supplies that can work if it's applicable. There's, the use of bricks and things like that you go get from the guys that make the bricks and the filters, et cetera. This is the part that gets, it explains where the difficulties are sometime in procuring systems. And this is a slightly different approach than the previous speaker, but it's sort of the same. We have a lot of the same perspectives. Back in the old days, the customer used to provide at least a requirements document to be able to go buy a system. How many people here, continue to get bombarded with single sheet or email-based system requirements, where you've got to go in and propose a real system based on really, really scant information and very limited requirements? And it's, the answer is that happens a lot more than you think. It depends on who you're buying the system from and how mature, well, that's not the right word, how mature the buyer is as far as making sure that he gets exactly what he asks for. A lot of people give very, very scant direction, and you've got to go out and compete with somebody, and you're not really sure exactly how to go bid this because they haven't defined what it is that they're trying to do well enough. So
they also want a price.
Right, and they also want a price with you. Now, and yes, the price is a ROM, but once you put that price out there, that's your price. It's just virtually impossible to go in and change it. Without betraying the trust that you've built up over a period of time with this particular supplier. So it's a no-win game. It's Russian roulette. You develop a good relationship with the suppliers. They come to you with a one-page set of specifications. You have to go design a system and give them a price that ultimately you're going to get held to. And if you come back 3 months later and say, I can't do it for that, the requirements have changed, I got creep, they're going to shoot you, and you're going to lose your trustability will certainly suffer here on the next project. Customers, basically want to pay for a custom system that is exactly what he wants, but sometimes they don't tell you what they really want. But at the point now, you go to other customers, sometimes the more sophisticated ones, and the customer doesn't even want to look at a solution unless it's COTS or, virtually, completely, 100% already done. They don't want to develop anything. They say, I can't pay for a development effort, knowing full well that nobody has what it is that they're, this widget that they're looking for in the system. So then it becomes, how can you quickly go off and develop something or claim that you're developing something to be able to meet the requirement that everything is COTS. Historically, engineers would design and build this. When I was designing systems, we would design and build a system that was exactly to the specifications of what we needed. If the spec parameters were rigid, then we would go in and sometimes take costs into consideration, sometimes not. We would usually design and build the most elegant, from an electronic perspective or avionic perspective, the most elegant solution that we could come up with without necessarily taking cost into consideration. Recently, the number of standards has increased, that you have a lot of different usable standards out there to go solve a lot of different problems that are in the marketplace right now. And fortunately, there's some bad standards that didn't catch on or simply, have fallen by the wayside. So a midplane system, what does that look like? These are some examples of some midplane systems that I've been involved with. And these sort of things lend themselves to that kind of an approach. We had a display, a display with some VNX modules that plugged into it. So that way you could take a VNX module, plug it into a display. You could change processors easily. The one next to it was, well, in that case, it was video frame grabber, but it could have been, anything else. It could have been a bus interface where you could slide in, slide out, something that would talk on a CAN bus or talk on a Victory architecture bus or talk on an avionics data bus, something like that. So you got a reconfigurable system that you can pull the modules out and get, things that are fairly upgraded. Or even more importantly, I found out, it made it more maintainable since, touchscreen displays tend to not have a very long life in a battlefield environment. This way you could change out all the displays without having to redesign the whole thing. Another midplane design that was basically the same. Yes, sir? Oh, it's my 5 minutes, got it. Midplane-based design that I was describing here, that would take and put in a small package, a COM Express board, some mini PCIe sites, an XMC card, and then some standard options and things like that. And it works very well. Exactly the same architecture you can apply to this 3 ATI or 4 ATI instrument and be able to use plug-in. I become a fan of COM Express, for the class of COM Express boards that are out there that are really good to go conduction cool and the like. I think that offers a lot of possibilities and promise. So what we try to do is to go build a custom midplane using the best standards for the application, which generally has taken the size, makes the size smaller, makes the system reconfigurable, gives you more choices for I/O, and often saves cost. An example for a cost is if you have a 2 or 3 slot 3 UVPX type system, but you've got really minimal I/O or scant I/O that you don't find on the same board, and you don't want to design a custom one. You put a processor in, and if it's an Intel processor, it doesn't really have a PMC or XMC site on it, so you've got a 1553 interface on another VPX card, and you've got some analogs and discretes or something like that on a second card. So in this case, you paid for the overhead for the VPX and the size that's associated with it to be able to put in functionality that you could get in smaller modules. So you could solve that with a VPX and a carrier with smaller modules, or build a hybrid system that just puts the modules directly down on a midplane and just call it good. There's a lot of applications where that would work real well. The other thing is products or projects. Over time, more and more embedded hardware providers are trying to design products instead of projects. But there's a paradigm out there where people do projects where you take the first one and then you try to evolve it into your next project after that. You have a different mindset when you're trying to come up with this compromise in the middle where you can design a product that will meet the requirements of a lot of people, of your segmented customer base. And I believe that that's a good thing to try to go do. Not all companies can make that transition. A lot of people start to do that but don't do it well. And because old and very expensive habits are hard to break. The big thing that these initial NRE costs are generally borne by the system provider, as opposed to being paid for by a customer that you're designing this thing for in general. So if you're designing a product, there's less propensity for requirements creep. And the requirements creep is the killer of profitability for doing systems in the COTS marketplace. Customers now expect to pay for customized at a COTS price. We're advertising COTS, we're COTS providers, but they want to come in with some sort of very customized solution. And when they think about what it's going to cost, they generally want to pay what they think that it would cost them to take their very best engineers, put on the project, and be able to go execute something in 6 weeks. That if you go think about it, it really can't be done in 6 weeks. So the customer, and then you do that if you get people that have poorly written specs, then customers creep and requirements along the way, and the scope creeps, and you end up spending a lot more money than you really intended to. Customer eventually ends up with a proper solution in general at a price generally higher than expected, often with extended delivery schedules. And taking shortcuts has been shown to end badly. This is what I consider a Clydesdale that was designed from a previous project. You don't always get what you think you're going to get. Most of us, if we're honest, we try to avoid small quantities, prototype programs, science projects, etc. But sometimes dealing with those things allows you to go in, if you're building a product, allows you to go build a product that you can actually take into the project marketplace and do well on if it's well engineered and well thought out. If you have a chance to think about how you want to design something before you put it out on the street, or before you try to make it fit a particular customer, sometimes you can have really good results. Typical system, just one slide. A typical system, that I would talk about, something like a COM Express Type 6 or a COM Express Type 10 single board computer. Those are really good because you can actually drop in a Type 10 where you drop a Write 6 and that into a Type 6, and that gives you processing that you can scale in the same hole all the way from with careful system design all the way from an ARM to a Xeon, and everything in between. So you can go pick the right processor for the right job once you've established a base of good components to put in it. The main XMC payload cards, for these sort of small systems, you can put a graphics processor, you can do video in, video out, compression, overlays, all that kind of stuff. Software-defined radios are a really good example for something like this, where you just need a processor and a radio and maybe a 53 interface and some interface to storage. Sensors, we've started putting in, the ability to put in an inertial unit, an INU or an IMU or some sort of you can even get tactical grade, MEM sensors now. And, typical applications are display processors, digital map video encoders, et cetera.